Hello and welcome to this instructional video. My name is Peter Musyoka, a trainer at Madenge Technical Training Institute in the Mount Kenya region in Kenya. Today I would like us to look at semiconductor theory and try to understand some of the basic concepts in electronics. Let's begin by asking ourselves, what are semiconductors? So these are materials whose electrical conductivity properties lies in between those of insulators and conductors. Semiconductor materials within the periodic table lie within the group 4, or we may say that are group 4 elements. And that is where we are going to find elements like silicon and germanium. We may compare the electrical properties between conductors, semiconductors, and insulators. Beginning with electrical conductivity, conductors have high electrical conductivity or have high conductivity properties. Semiconductors have medium, or we may say have variable conductivity, while insulators got low conductivity. In regard to band gap, conductors have a very small or none band gap. This is because the valence band and the conduction band overlap. Semiconductors got small band gap. If our material is germanium, then the band gap will take 0.6 electron volt to bridge, while for silicon semiconductor material, the band gap will take 1.1, approximately 1.1 electron volt. Insulators got the highest band gap now in reference to our materials here, with more than 3 electron volt. Here is an energy band gap diagram, what we have just discussed. From my right, you can see the conductors, whereby the valence band and the conduction band overlap. Or for the semiconductors, there is a gap between the conduction band and the valence band, which is what we are calling the band gap. And we have seen for silicon you require 1.1 electron volt to bridge that gap. For germanium, approximately 0.6 electron volt. With insulators, we have the highest band gap between the conduction band and the valence band, and again we have seen is greater than 3 electron volt. Finally, our semiconductors, or generally semiconductors, are categorized into two, where we have intrinsic semiconductors and extrinsic semiconductors. Intrinsic semiconductors are pure semiconductor materials, while extrinsic are materials that have been doped with impurities in order to increase or alter their conductivity properties. Further, extrinsic semiconductors are categorized into two. We have N-type extrinsic semiconductor and P-type extrinsic semiconductor, as seen within this lattice. Thank you.